Maven is called as what? Build tool, right? Build tool. Why we call it the build tool? See this, if you have taken the demo, this is what we discussed. Now we are going to start working on our project now from Maven tool. Okay, so Git is just how you modify the code, how you push it, correct? There is no project requirement there. But with Maven, yes, we'll bring our own project. So this is your team users. This is the Git server, right? So what we are going to do now, you have 100 users, okay? Dev team, DevOps, anybody, they all commit the code. I mean, they all modify the code in their local machines. Then we know how to push this code to Git server. So once we have the code in Git, right, repository, then what we do, we take this code, we clone the code as a DevOps engineer. Every day they commit the new code. So let's call it as source code, whatever we have here, source code. Source code can be anything. It can be Java. There may be some CSS files. There may be some HTML file. There may be some XML, whatever. There may be some images. So we don't usually write this. This is job of development teams. So every day users commit the code to Git. Every day as a DevOps engineer, we take the code in a new machine. Let's call it as build server. Build server. And guess what we do? Once we take the code, we have to compile the code. Here we have to compile the code using a tool called Maven. This is where Maven comes. If you have taken the demo, you know this, right? Why we have to compile the code? Quickly see this. So developers write the code, for example. So this is login.java. You execute it, you have to see login button here. That's an output. That's what you execute it. That's what you expect it. But in real time, sorry. So this is the plain text, right? Say button, some Java code you will write, say for example. Expectation here is you execute it, you have to get login button, but you cannot directly execute this text format. This is a plain text, right? We call it the source code. Source code, or you call it as plain text. You cannot directly execute text because machines don't understand. Correct? Machines understand what language? Machine language. Correct? So we have to write the code in binary, something like this, or some machine language, low level machine code. This is machine code, or you call it as executable, machine executable code, or we call it as binary. Is it possible for us to write the code in binary like this? Very difficult, right? For example, here it is very easy for us to write code something like this. C is equal to say 10 plus 12, for example. It is very easy. If you have to write the same thing in binary, you have to do something like this. 10 means 1010 plus 1100. You have to write code something like this. Again, you cannot write C here. C you have to convert it to equivalent ASCII. Again, you have to convert that to binary. Equal to. Also, you have to represent in the binary. Semicolon in binary. Very difficult for us to write the code something like this. How do you convert a number to the binary? 8421. 8 plus 2, 10, 0, 0. 8 plus 4, 12, 0, 0. 1010, 1100. See how difficult it is for us to write the code in binary. So the question comes, right? How do you convert your code that is written in text in machine understandable language? For that, we have to compile the code. Compile it. When we compile the code, what happens? Compiler checks the language syntax, grammar rules and everything. If you are following .java syntax properly, then what it does, if you have say 100 lines of code, it generates equivalent 100 lines of machine understandable code. In Java world, we call it as class file. So if you compile login.java, you get what file? Login.class. This is what you have written. This is machine understandable code. So in real time, when you have 10, 20,000 .java files, correct? You have to convert all these 10, 20,000 .java files into equivalent 10, 20,000 .class files. Otherwise, you cannot execute the code and then launch the application. Now you have the class file, and then you run this particular code on some operating system, you can get the output. Login button, search box, or it can be anything, calculator application, it can be anything. That's how you make the code run as an application. So until and unless you compile 10, 20,000 .java files, you cannot see the output. Okay. So in real time, it is developer who writes .java code, and as a DevOps engineer, what we do, we have to compile the code. So when we compile the code, say we get say 10,000 .java files here. We have some HTML files, some CSS files, images, and things like that. So we take the code and then we compile the code. Do we compile the code manually? No. It takes more time, and then it's not, it's error prone also. There is no guarantee that you'll be able to compile all this 10, 20,000 .java files without any mistakes, without leaving something. Very difficult. That's where we think about some tool, and the tool is what? Maven. Using Maven, you can compile thousands of .java files and then generate class files. Right? That is machine understandable code. How we compile it? That's a subject. We'll discuss that later. So you compile and then you generate 10,000 class files. Okay. But to run the application along with the Java code, we need to have a lot of other supporting files. We may need some HTML. So we have everything right here in the Git repository, HTML, CSS. So whatever files are required, we copy everything in this particular folder, HTML, CSS, for example, images. We call this as build process. Build means this is the source code. We cannot launch application, kind of a raw material it is. Somebody has to take the code and then compile it and then separate all other files which are required for application to run. And do we do all these things manually? No, we automate this process, right? So once you have everything here, then we compress this particular folder and then we create something called var file, flipkart.var. Var means a zip file, okay? Web archive. It's kind of a zip. Like we have .zip, .rar, .tar, .tar, .gz. These are all archives, right? Once we have that particular var file, now you can launch the application from that. Okay. So how do you launch application now? You have the var file, right? You copy this particular var file into this particular server. Here you have to have some application server like Tomcat. There are different servers, like we have Tomcat, we have JBoss, WebLogic, WebSphere, and things like that. So you have to take a mission, you have to install Tomcat. Once you install Tomcat, you get a folder called Web Apps. Okay. And in that Web Apps, you have to go and copy this particular var file. Don't worry about that low level details. So this is your mission, DevOps engineers laptop, say for example. So DevOps engineer every day, this is kind of a regular activity for us. Every day morning we go to office, we clone the code, we run some Maven command that will create the var file, and then we copy this particular var file into this Tomcat server. Of course, we don't do all these things manually. It will be having separate servers. Okay, think in that way for now. We call this as what? Deployment. Deployment, or we call it as release. And this server will have some name. For example, let me call it as flipkart.com. So now you can launch the application. So end users, how do they access the application? The moment you type flipkart.com here, browser is called as a client. All these web applications work based on client server architecture. You are opening the browser here and then you are typing google.com. Means what? This is the browser is client, right? Google.com is what? This is the server name, google.com. So the moment you type google.com here, this browser will connect to google.com. And google.com, they have the code. Client sends the request to the server. Server processes the request. Server executes the code. Then server sends response back to browser. So that's what is happening. For example, now I'll just search, Apple, say for example, right? Okay, something like this. Lenovo. The moment you do something here, what happens? Again, browser sends this to the server. Google server may be connecting to some database and it is executing some code here and then it is sending you results. So you got the results here. So this is client and this is the server. Okay. All web applications work based on client server model. Now you see how this users, how our developers code is kind of becoming as an application. So to make this particular code as an application, somebody has to build it, deploy it in the server, start Tomcat server here, then only our real users can access the application. This guy is the end user. But in real time, we don't directly push that code to flipkart.com. We have to test it, correct? So it can be end user or it can be QA, our testing team. So for testing team, what we do? We'll be having, separate test environments. This is production environment, flipkart.com. In real time, we'll be having what? Test environment. Say this name is flipkart-qa.com. So every day what we do? Every day developers write the code. Every day we take the code, build and then deploy it into flipkart-qa.com. And our QA team types what? flipkart-qa.com. So they connect to this particular server and then they will test daily bugs, features and everything. And somewhere here we have another environment. This is flipkart.com production. So live users are connected to this and our testing team is connected to this server. We call this as what? Test environment. Environment means a server, a mission, right, where your code is installed, where your code is deployed. This is test environment. Remember this, test environment. This is production environment. We call it environment. In real time, we may be having n number of environments. This is only one environment, QA. You may be having flipkart-say sit.com, system integration testing. You may be having one more environment, uat.com. You may be having, say performance.com, flipkart-performance.com, different environments. So one team connects to this, they do manual testing and the automation testing. Integration testing team connects to this URL, right? We have to deploy the code to this also, same warfare, right? Our different environments may have different code basically. So system integration testing, right? Maybe this is for UAT, this is for performance. So we first do manual testing, then we go to system integration testing, then we go to user acceptance testing, then we go to performance testing. Once this code, right, war file is passing all these test cases, then we deploy to production. So we may be having multiple test environments. I'm just explaining this at a very high level. Okay, in Maven class and Jenkins class, we'll be deploying the code to different environments also for our project. So now we understand what is the role of Maven in DevOps lifecycle. Maven compiles the code, it builds the application for us. Any questions so far? Right. Here, I said it creates the war file, right? It is not actually the war file. Before war file, right? We have to do a lot of other steps. We have to do a lot of other steps also. Okay, before war file. You see this. This is what we do in real time. Developer writes something called login.java. Okay, As we discussed, we compile this. And then we generate what? We get what? Login.class file. Once we get the class file, then we have to combine multiple class files and then create something called jar file. Login.jar. In real time, you'll be having code something like this. For example, if you go to Flipkart, you won't be having complete Flipkart code in one folder. Login code, payment code, cart, everything. No, not everything into one Flipkart folder. No, we will be having different folders having different functional code. For example, under Flipkart, you see login. This is login code. Payment related code. So usually we call that as what? Modules. Based on the functionality of the application, right? We split the application into modules and then we store the code. This is login, as I said. Payment, your cart related code, right? Your search related code. So this is how you have, this is how your project code looks like. And of course here the parent folder is Flipkart. Login may be having 100 files. Cart may be having 100 files, 100, okay, 200, whatever, correct? So as we just discussed, assume that we have login.java and we have 100 files basically, correct? Lot of .java files. We compile all these .java files and then we generate what? Login.class. Not one class, right? 100 files, 100 .java files, 100 class files. Okay. Same for everything. What I meant to say, instead of taking one file, I'm taking hundreds of files now. Okay. So 100 .java files, 100 .class files. Okay. Once we have 100 class files, then we have to compress all this class file and then create something called login.jar file. Okay. What we do? Jar is again kind of a zip file. It is like you have login related 100 class files, .class files. You combine all this login related 100 class files and then you create a single file. So if you extract this file, you get 100 class files. It's like a zip file. Java archive. Since it contains Java related class files, you call it as Java archive. It is like another kind of zip file. We have to compress like this. Similarly, we get multiple jar files, right? Correct. See, this is for the login. So module wise, usually we create one jar file, or there may be multiple jar files also, right? I'm just explaining the concept to you. You have search dot Java. Search has say 200 files. You compile all these 200 files and then you generate what? Search dot class 200 dot class files, correct? Then you create what? Search dot jar file. So you have login.jar, you have search.jar. You may be having multiple jar files. Again, we combine all these jar files and then create something called var file. Flipkart.var file. This is the final file that we create. Flipkart.var file. We call this as build process. What's it? Build process. Java build process. If you are working for Java applications, this is what you have to do. Build process. So once we have the var file, then only we deploy this var file here. It's a process. Okay. You asked me the question now, why we have to create the jar file? You know the reason for the class file, right? This is machine understandable code. Why cannot we directly, take all these hundreds of class files and then deploy here? You can do that, right? Instead of creating the var file, you have 10,000 .java files, right? You generate 10,000 class fields and then you can place 10,000 class fields. That's totally fine. It works. But we have to package it. See the word terminology? Package. We have to do the packaging. This is a package, pack of class fields. So var is collection of jar fields. Jar is collection of class fields. Class file is binary equivalent of machine understandable code of what? .java file. So we have to do this. Why we have to package this? It is not required, but just for the convenience purpose. That's all. Right? If you have multiple class fields, it's very difficult for you, to copy, and things like that, right? If you have everything in one package, then it is very easy for you to maintain it. Correct? Easily maintainable. Again, if you ask me, I'll take a very basic example, right? You grow apples. Okay, apples. You are a developer, okay? You are a product owner. You grow apples. You have to ship your apples to your customer. What do? Do you ship apples one by one? No. It is inconvenient for you to load all the apples to the truck. For user also, it is inconvenient, right? So what do? We package it, right? We create a package and then this is jar file. You package all the apples and then you ship your product to your customer as packages. In software also, we ship our application code to the customer as what? Packages. You want to send 100 photos to your friend in email. Do you attach one by one? What do? You combine all the photos and create a zip file and then you attach a single zip file, right? How convenient it is. It is just that, that's all. Okay. Okay, jar file. You can have one jar file, right? But in this case, you have multiple jar files. Here also we can create the situation. You have some green apples, blue apples, red apples. Can you, see here, this is what I'm explaining, right? You have multiple jars, right? You can copy the jar files also. But again, if you create a one bar file with all this jar, it is again convenient for you. It is like this, see. You have kept blue apples here, red apples, green apples, everything in one package. You're shipping to your customer, right? User. This guy again has to separate, right? Red apples, blue apples, green apples, if it's a one package, correct? So what do? You create one package with red apples, one for the green, one for blue, for example, and then you ship. You have different, say, packages. You combine everything into one package again. This is a var file, individual jar file, jar file, jar file. So you ship this to your user, it becomes even easy. Understand that? So you can ask me one question here. When, right, we can combine all the class files in one jar file, why we have multiple jar files? Why we have multiple jar files here? You can combine all these class files in a single jar, okay? Login, cart, search, payment, all dot class files we can combine in a single jar file, but we want module level, right? Division, right? It is like module level, right? So green apples, login code in login.jar, green apples here, right? Red apples in here, right? Blue apples here. So login code is in separate login.jar, right? See, we can combine all these class files in a single jar file, yes. But if you have multiple jar files, then we have, it is very easy for us to identify only the login code, search code. Tomorrow, if you modify login code, you have to create only this login.jar. You don't need to touch any other code. If you are combining all the class files in one jar file, even though you modify login, you are forced to create the jar file with everything now again, right? So more smaller it is, more manageable. Correct? What I mean to say, in real time, we won't be having complete application code in one folder, right? We have modules, different modules, names. If you clone, say, for example, Flipkart code today, go and clone Flipkart code. Of course, it's not open source, right? You see something like this only: login, cart, search, pivot. There may be a different multiple modules. So what we do using Maven, we compile all these modules and then we create different jar files for different modules. Again, this module may have the multiple jar files It depends. So basically, you compile it, you create a package, right? For module level, I mean at a module level, then you combine everything and then create a var file, and you deploy that particular var file into Tomcat server. So this is how we build Java applications. Okay, we don't need to know Java, right? It is like this. Developers, are experts in writing the code. They say we have written the code, right? We don't know how to ship our product to the customer, right? Can you help us? We are experts in that. We are build experts. We know how to build softwares, correct? We know how to build softwares. Is this a software, right? Is this the application? No, right? You cannot launch application, right? We know how to build the applications, right? Application building, application means compile it and then create separate packages and then, right, things like that, and then deploy it so that people can access it. We are build engineers. Earlier DevOps engineers used to be called as what? Build and release engineer. I started my career as a build engineer. I went to my native, right? People ask me, okay, you got the job, right, after BTech? I said yes. Okay, what kind of job it is? I said I'm a build and release engineer. Build and release engineer. Then people started asking the question, okay, you are a computer science engineer, right? So what do you do when you say, what do you mean by build? Do you build, kind of say the bridges? I mean, in civil work, right? Do you build buildings? Is that you are a build engineer? I said those people build buildings and then the projects, right? I build applications. You understand this? So this is the raw material. We take raw material and then we build the applications. In their case, sand, wood, right? Their raw material. It is the raw material. Is this a final product? No. Civil engineer has to take this raw material, right? Shape the wood in a different ways, right? Filter the sand and a lot of things. He'll take the raw material and then he build the final product, right? Application. He'll build the final product. So they build buildings, we build applications. Correct? This is the raw material. This is not application, but this is not executable application. So we take this code and then we build the application. Then I said, I build applications, application softwares, not the buildings. Kind of. Just to give you that easiness, okay? Just for your better clarity. Okay. So what I'll do now, I will, write a small Java file, some simple Java file, hello world Java file. I will compile it. I will show you how the class file looks like. I want you to see the class file. Then I will create a jar file manually. Then I will show you how difficult it is for us to compile the code manually. As I mentioned, in real time, we have 10-20,000 Java files, right? So you have to compile all those files and then we may need to create multiple jar files, hundreds of jar files. It's not possible for you to manually compile and create the jar files, correct? So, but I want you to see how a Java file looks like, how class file looks like, how jar file looks like. Let us first do the things manually. Let's feel the pain, right, of doing something manual. Then we'll think about the Maven, right? So how painful it is for us to do all these things manually. Then we'll introduce Maven and then let's see, like, we'll learn how Maven helps us to, right, bring us out of this manual task. Okay. We are not Java developers, right? We learn the things from core, right, from the base. So I want you to see at least once how the Java file looks like, right, so that you feel very comfortable in real time. So here only I'll just write some code. I'll say vim number.java, numbers.java, public class numbers. This is not Java class, so I'm not explaining the code, right? But for your information, usually in Java, right, whatever file name you have, right, numbers. Here also the class file name should be same. That's a rule in Java. And any Java file you take, there should be one main function, public static void main. This is a main function. String args. So I just want to write, integer. Okay. I want to display numbers, okay, from 1 to 10. I'm writing the code for I is equal to 0, start from, okay, I is equal to 1, start from 1, I is less than or equal to 10, go till, 10, increment 1 by 1, plus plus, post incremental operator. Think that, I know, even I know writing only this .java file. We are not Java developers, okay? I worked, as a Java developer initially after my, BTech. Like, I liked it. I mean, joined as a build and release. It was a start, a small company, a 10, 15 people company. Everybody has to do everything. So I got a chance to work in Java for 1 year. So I know little bit of Java. Okay. DevOps engineers don't need to know, right? I'll say system dot out dot println. I don't remember any, other Java syntax now. That's my skills are rusty now. Not required. System dot out dot println. Why I'm telling this because to give that confidence, right? You understand? Otherwise, people think that okay, I'm writing the Java code and then you are not able to write Java code. I've never written a single line of Java code in my DevOps career. No. Out.println, let's say say number. Let me print it as I. Okay, I. So this is how a basic Java program looks like. Fine. Now, can we directly execute this .java? No, right? You want me to execute Java. So Java is the command to run Java code. I'm running it. Numbers dot Java. See what it is doing? What it says? I'm running the code, okay? If you want to run Java code, what command we use? Java. Remember this. Java is the command to run Java code. Could not find or load main class, right? We have the main class in .java, but it says I cannot find it. Why? Because it is in text format. Machines don't understand what you have written here, correct? So it says I cannot find any, say main class there. It is there, in fact. So what do? We cannot directly execute .java. We have to compile it. If you want to compile Java code, there is a command called javac, Java compiler. Java compiler is to compile and then generate a class file. Java is to execute the class file. Understand that? We first compile and then generate class file. Then we use Java to run that code. I'm compiling it. See what it says? It says cannot find symbol I. Okay. Cannot find symbol I. So wherever there is I, it is showing that error. It says 4 compilation errors. In real time, do we need to fix these compilation errors? No, we don't know Java. So here we take the code 10,000.java files. No matter whether you are compiling it manually or using Maven or whatever it is, right? If when we are compiling the code here using Maven or manually, when there's a compilation error, what do? We report it to the developers. They fix it in their local machine. They again commit the code to Git, push the code to Git. Again, we take the code, again we compile it. So until we generate this war file, we'll be closely working with the development teams. And once we have the war file, we deploy it, and then we send an email to dev team and then QA team saying, build and deployment is done. Your code is in QA.com. You can connect to this and then you can do your daily testing. That's what we do. And we automate this process. It's not like, there is some compilation error. We open, email and then we compile the email and then we send. No, we don't do all this manually. We automate it. When there is some compilation error, our tool should be automatically send an email to that, user, whoever broke that. Somebody unmuted. Question.
Sir, which compiler or like what environment should we download for compiling a C program?
I will take that question at the end. Fine. I'll take it at the end. We're in flow. Let me just complete this. I'll take it. Okay. So here you report it to the users. Fine. So that's what happened here. But I'm a developer, I know the compilation error, correct? So I'm opening this. In Java, without declaring a variable, you cannot use it. Int I, okay? So I variable is not declared basically. Java is a strongly typed language. Before you use a variable, you have to declare the type of that particular variable. Don't worry about that. It's Java, right? We don't need it. And instead of just blindly, doing something, I'm explaining that. Okay, compare it. Correct. So you see here, that class file. This is what we have written. This is for mission to execute it. So once we have the class file, then we execute the class file, and then we get the result. So Java C is for the compilation. Java is for running the code class file. Okay. We should not give dot class. By default, it will take that dot class file only. Okay. As a syntax, as a rule, we should not give dot class, but it is actually executing dot class only. See. Now this is machine understandable code. Machine can understand, right, our instructions. Java is what? It's a language, right? Language to communicate to your computers. When I was in BTech first year, my senior used to come to me and say, "Hey Nagesh, I know how to speak to computer." I said, "How you speak to the computer? It's iron." Kind of, right? So then he said, "Okay, I know I have just learned a computer language, so we both can communicate with each other." So what we have done? We have written instructions here, right? I'm asking computer, print numbers 1 to 10. So that is the language, right? I learned Java language, right? And then I'm speaking to the computer, and the computer can understand it. So can computer understand this plain text? No. We have to write instructions in its own understandable format, right? So it is understanding my language, and then it is communicating with me. I asked, and then it is giving me the output. Okay. Fine. So recently, there is a company, right? White Hat Junior. They give coding classes for kids. Right? You would have seen. It's very popular. There was a demo actually, for my kid. So the lady was explaining the same thing. Okay. So how do we, talk to the computer, right? If I say, "Hello computer, print numbers from 1 to 10," it cannot print, right? It cannot understand. So she took the same example. She said, the English is between you and me, and then Java C is between we and the computers. She explained it very nicely, basically. Okay. So fine. So this is how the class file looks like, right? So ls. Now you open this class file. You want to see how it looks like? See, this is mission understandable language. We cannot write in this language. Now you clearly know why we have to compile the code. It's a Java. You take any other programming language like C, C++, .NET, you have to compile those things also. In case of Java, it is dot class. In case of C, right, you get .o. Say login.c, you compile login.o. Okay, object file they say. Maven is for building Java code. Java. For C, we have something called make. C and then C++. For .NET, we have a tool called MS Build. MS Build. There is another tool called Ant. A-N-T. For Java, it is ANT. And then Maven. Ant is a old tool. Maven is the latest one. In C, this is the old we have. In .NET, we have tools. MS Build and then Ant. We are learning this. It's a Java world. 80 to 90% of the applications are Java. Okay. You may be thinking, right? I don't know how to compile C code. I don't know how to compile .NET code. We don't do much things here, right? So it is like just you run some C command, it will automatically compile it. And most of this Maven code and then make .NET code, right? This Maven configuration files are written by developers. 90% of the Maven configuration files will be written by developers. So if you know one, it is very easy for you to understand. You may not get a chance, It's a very rare chance that you get a chance to. It's very rare that you get a chance to work in C, C++.NET. When I was in NetApp, right, I got a chance to work on C, right, compiling the C. But you believe me, I never had to write any make files here. I never had to. Automation would be there already, right? Most of the times, if at all something required, you may have to change little bit of configurations. But this is just for I think 1 year. That's all. And rest all like it's a Java. Java is everywhere now, right? Also, you take Flipkart, Facebook, right? When Facebook Star One was built in PHP, right? Initially, again they must be having Java now. So Java is world famous, right? Everywhere it's a Java world. When it comes to the application, people by default take Java. That's how. C, C++ is usually used in networking, storage kind of applications where you have to interact with operating system and hardware. C language is very powerful. That was the question, right?
Nagesh, what in case of Python?
What is the question exactly? Can you repeat?
No, just like Java, what would be the case for Python?
Okay. See the question now. It's a Python, right? We don't need to compile Python code. You don't need to compile shell. You don't need to compile Perl, right? Those are all interpreted languages. There are two kinds of languages. One, compiled programming languages. Then what we have? Interpreted programming languages. Interpreted shell, your Perl, Python. These are all interpreted. Ruby. Compiled Java, C, C++, .NET. These are all the compiled programming languages. End of the day, you have to give machine understandable code to machine, otherwise it cannot understand. So when I say interpreted, we don't compile here, correct? What happens if it is Java, right? What we do? It is login.java. We compile it and then we generate what? Login.class. You execute it and then you get the output. So this is basically machine understandable code. So before executing it, right, and then you execute, you get the output. Before executing, you are compiling, and these languages are designed in that way. Before you execute the code, you have to have the compiled code. Understand that? Okay. Java is compiled and interpreted language. I'm making it complicated. Just forget that sentence. I'll come back to that later. Okay, so before you execute, you have to compile this, right? Now you have the machine understandable, you get the output. In case of interpreted language, what happens? You can directly run the code. So you have login.py, Python code. This is plain text, yes. You can directly execute it. So, but it's a text, right? How you are able to get the output? What happens? At the time of executing the code, right? Here, so you execute, right? Say, for example, Python login.py. At the time of executing the code, that code will be translated to machine understandable and then it will be executed. So at runtime, your text is converting as machine understandable and then you are getting the output at runtime. So at runtime, that conversion is happening, right? Text to machine understandable language. We call that as an interpretation. If you are converting that source to the binary at the time of runtime, you call it as interpretation. Okay, these are all interpreted languages. Since you are converting at the time of runtime, interpreted languages are slower than compiled languages. Why? Because you already have the compiled code right here. You already have the compiled code, so execution is fast because this conversion is not happening at the execution. That means you click a button. If it is Java, C, C++ application, right, you can launch it very quickly. You can see the screen, you can see the application on the screen very quickly. The execution is fast in case of compiled because you already have the compiled code. But here in case of interpreted languages, the execution is slow because the conversion is happening right, at the time of runtime. So there are compiled programming languages, interpreted programming languages. Compiled programming languages are faster than interpreted. So if you take any large size enterprise applications like Flipkart and all those things, they prefer compiled programming languages. Of course, Python is also good. It's not very slow, but it's compared to, when it comes to the performance, interpreted languages are slow. Then why do we use this then? Question, right? Why do we use this then? Developing something with these languages is very easy. Is very easy. It takes less time for you to develop something. That's the reason we usually for non-performance critical applications we can consider these things. But if it's a critical application, it takes more time to develop. More time to develop using this. More time to develop, but faster execution. So if you are worried about faster execution and don't worry about the development time, you take this. It takes more time to develop the application, but it's fast. It takes less time to develop the application. It is slow, right? Usually that's the reason we call this as scripting languages, right? This is programming and this is scripting. Usually in real time, right? When it comes to any automating internal things, right? For example, you have some 100 machines, right? You have some 100 machines. You want to check the disk space in all these 100 machines. Do you write Java code or you write shell code? You write shell scripting or you write Java code to automate this process, to find the disk space? We don't prefer Java code, right? We don't write Java. Using Java code also you can identify the disk space, right? In all this 100. Say if the disk space reaches 190%, you want to send an email to your team saying, in 100 missions, disk space is reached to 90%, right? And things like that. You can automate that using Java code or you can using shell code. If you write Java, it takes more time. If the shell, you can just get it done, with 2-3 commands basically. Performance doesn't matter for you here because it's your internal automation. When it comes to internal things, usually we use this, right? Python, Ruby. When it comes to the applications, the real applications, we use this because we don't mind in spending more time, but speed is very important for us. Compiled programming languages, interpreted programming languages. Okay, Java is actually both, right? We have to compile, and that at the time of you see this, right? This is not pure binary, right? Is it pure binary? No, it is a simplified version of the binary. So again, the class file will be converted actually. The class file will be again converted to the pure binary and then it will be executed. It's a compiled plus interpreted language. But we have already simplified something, right? So it is faster. That's how they have designed it. So we don't compile shell, Perl, Python, Ruby kind of interpreted languages. We directly execute them. Clear with that answer?
Yeah, so the interpreted languages doesn't come under the build process, so it is already pre-compiled.
Right. We don't not pre-compiled. We don't need to compile. Say we have Python, you directly copy the Python files here in the mission, and then you execute it. We don't need to compile.
Okay, so if there are any errors like
and .css.
Question?
how so if there are any errors, how do we come to know or how it is notified?
At the time of execution, you get that if there is any syntax error.
Okay.
When developers write the code, they usually run it and then commit the code, right? But if there is syntax error, yes, we get that only at the time of runtime. Okay, think that as a kind of a disadvantage.
Okay.
Okay, so you know how to compile the code now, right? See, we are talking about only one file here. Again, if you want to create a jar file, this is how you create the jar file. We don't create the jar files manually. Don't worry about this command. If you want to create a jar, you say jar-cvf. Okay, create verbose. Verbose means whatever file it is adding to the jar file, it will show you one by one. Okay, create this particular file. For example, say number.jar. Okay, include this class file. With a jar, create C for create, X for extract. Create this particular file called jar file. Include this class file. rm-rf numbers dot class numbers dot java. So we have got jar file, right? In this jar file, what I have class file, right? So let me show you here so that you understand very easily. Desktop, see the jar file. It is like a zip file. You can extract it. Extract here. So this is extracted folder. You see there is a numbers dot class. In real time, in the jar file, you include multiple class files, like all login related class files. You combine and then you create one jar file. How difficult it is for us to compile like this, and then choose different files to go in different jar files, hundreds of jar files. How difficult it is. That's where, right, we think about a tool. Correct? Let me open the notes. So what we have discussed today about Maven, end-to-end Java build and deployment process, correct? How developers develop the code, right? And then how you build it and then deploy it. How your QA or end users access the application. You know that at a very high level, end-to-end, right? You know how a Java program looks like. You know how you compile the code manually, Java C file name. You know how difficult it is to compile the code and then create the jar file and stuff like that. That's where we think about the tool. And what is the tool? Maven. If it is Maven, you can automate that process very easily. So what is Maven? Maven is a build tool for Java application. When I say build, building the applications, compilation, and then creating that particular jar, var, and everything. So if you just run one command in Maven, for example, Maven install, it will automatically compile, create the class file, all the jar files, and then var file. But we have to tell Maven, right? We write something called pom.xml file. It is Maven understands XML syntax, pom.xml. So in this XML file, you write, okay, I want to compile this. I don't want to compile this. I want to compile this, and then I want this name for this particular jar file. I want to give this name for the jar file. I want to include all these jar files and then create this. I want to test something. So all those instructions you write in XML file and then just run one command. For example, if you execute Maven install command, what it will do? This is the command we have to execute. Maven, okay, Maven install. If you execute this in Maven install, wherever you have your Java code, right, this will compile the code. It will also run some unit test cases. I have not discussed. Okay, just forget about that word, unit test cases. It will compile the code. It will run the unit test cases. It will get the jar file. It will get the var file. See, with just one command, that's all. Right? That is the power of tool. So Maven is a build tool using which we can automate Java code compilation process and packaging also, that jar var creation. Why we need a build tool? We have seen all those things. That is the detailed introduction for Maven. So now next thing is what? Now we know what is Maven, where it fits in DevOps, and we should now install it and then do what? Build our application, right? Create all this thing we have to explore now. You have to write that pom.xml file and stuff like that. Okay. So here I have next class. I will give you our project source code. Our project is what? Gamut card. It's like a flip card. Okay, this is Gamut card, kind of a capstone project. That's all for today. So next class, okay, I will start with the installation. Let me just note it down. 8:30 p.m. weekend batch. We discussed till here. Any questions for today? You got a fair idea about what is Maven, correct? Okay.